Hi, I'm going to work out section 4.1 of Lyell's eText or section 2.1 from your hard copy of the book, which is about the inverse functions. The one-to-one function is the most important concept of this particular section. So to determine if a function is one-to-one, you do need to find out whether each x corresponds to a single y value or not. That means there should be no repetition in the first component or in the second component in a set of ordered pairs. Okay, if you think about a graph, you must realize that it should pass the horizontal line test. Okay, so if I just to explain these two concepts, if I give you a set of ordered pairs, let's say you do have something like 2 5 1 7 3 1, something like that, and notice in the set of ordered pairs there's no repetition in my first component and there's no repetition in my second component. So this set of ordered pairs will be called a one-to-one function. And to determine if it's a one-to-one function from a graph, if you think about a graph something like maybe like this one, and if you want to find out whether it is a one-to-one or not, you think about a horizontal line, and if there's any part of the graph that touches more than one point, it fails the horizontal line test. In this case it fails, so it is not a one-to-one function. Okay, few other concepts you might have already gone through, which is to determine two functions f and g, if they are inverse of each other or not. Basically, to determine you do need to do this f composition g equals g composition f, and that will equate to that x. Okay, and whenever a function is one-to-one, you know there will be an inverse function. Okay, so that's why we started discussing about that whether the two functions are inverse of each other or not. And if the two functions are inverse of each other, you know your domain of f will be the same as your range of g, and range of f will be the same as your domain of g. And if you think about a graph, okay, so if I give you something like this one, and you can see that it does pass the horizontal line test, so it is a one-to-one function, right? So it should have an inverse function. To determine how the inverse function will look like, think about a line called y equals x, and in my drawing it does not look quite y equals x. Okay, so let me do that line y equals x one more time. This one looks much better, and the graph of the inverse function will look like something like that. Okay, so the concept is basically to find out the inverse function. You just think about reflecting the graph across the line y equals x. Okay, now this is another important concept. Okay, since we were still considering about the inverse functions, let's go back to one important concept. Okay, this is very important concept. Once you have established that the function is one-to-one, you can always write down fx equals y and f inverse y equals x, right? Because if you know there are like mappings like this type, and maybe you have ordered pairs, and let's say 2 7 and things like that. So if I ask you a question like f1, you know how to answer that question uniquely, right? So if I ask you f inverse of 3, now you also have a correspondence, so you actually can tell me f inverse 3 will be 1. That's why this concept is very important. Once you have understood this part, this particular question is very relevant. So this one says that the graph of function f is shown. Use the graph to find f inverse of 8. Okay, so when you are working on this type of problem, notice one thing. When I say f inverse of 8, you have to decide what that 8 relates to. So is this a x value or y value? That's the most important thing to realize. And as I indicated here, whenever I'm writing down f inverse of y equals x, that does tell you that 8 is actually y. So what you need to do is basically read out the y value of 8, 1, 2, 3, 4, 5, 6, 7, 8, and find out what the corresponding x value will be of that graph. So if you look at the part of that graph that is this point, okay, so if you notice, I'm going to label it. So this is the point I'm talking about. So the corresponding x value is the one I'm looking for. So in this case, your answer will be 8. Okay, let me ask you this tricky question. If I ask you f inverse of 0, and a lot of times I get an answer something like 2, and that is actually an incorrect answer. You know why? Because this 0 reflects to your y coordinate, right? So if you